kunnen doen. Zo, klaar. Ladies and gentlemen, we're going to start in a couple of minutes. So grab a beer / pizza and have a seat. De persoon die is dus ja, ik wil wel een beetje. Ja, dat. Ik heb ook al You're also quiet. So, good to have you tonight. Welcome. And to the next Meteor meetup. We're going to have 2 talks this evening. Bob is going to talk about a project that he did at Q42, building the planning and how he's using event sourcing for that. And after that, I'm going to do a talk about GraphQL API that feeds this application. So that's what tonight is going to be about. And I encourage you to, if there's, if you have questions along the way or want to dig a little bit deeper into one of the topics that we're pointing in, please let us know. There's a pretty diverse audience from beginners in GraphQL and in Meteor to people that are running full-fledged production systems in it. So if you have questions, just ask them and we can dive into that further. The talks are going to be recorded by DJ Frank in the house. I think he has a lag because he doesn't hear me. Yes. Nice. So enjoy yourselves and here, Bob.
So I'm going to talk a little bit about our Q42 planning, our new planning. We had no planning, we built it in C# 8 years ago, and it needed to be replaced. And we used event sourcing for it. So I'm going to talk a little bit about that, but first, well, the Q42, as Lukas said. Some of you have already been here for the Meteor meetups. We did an Android meetup. Others have been in our office in Amsterdam, and none of us, except Lukas, has been in our office in America, in the Silicon Valley, Mountain View. That's where we have half an office. We have one colleague who cannot work.
The wall is missing?
Hmm?
The wall is missing?
No, he has a wall, but no working visor. So. Q42, we do all kind of projects. We build apps, we build websites, web application, smartwatch apps. I'm missing something? No, I think not. We also have our own projects and we do jumpstarts. Jumpstart is a project of 1 to 2 weeks where we build solutions for customers. Yeah, that's it. And we have our own projects like Handcraft, a little bit older, Xbus, we sold it, and the Rocket.
Listen up.
Listen up, thank you. Yeah, our Listen Up developer is looking really, really mad at me. So, that's a little bit about Q, a little bit about me. In Meteor, I built the master car configurator. I talked about it, I think a little bit more than a year ago. The talk is somewhere on Vimeo. Helped in the Volkenkunde Museum app, connected bike app I did for Gazelle. And we built together with Lukas and some other colleagues a connected hula hoop. Really fun project to work on, and it was even more fun to test it. We had the hula hoop a weekend long. But it was a nice project. What I also do here at Q42 is the internal tooling. And some of those tools are so you can call in sick helpers for billing, so everyone has an overview of the projects we do and the hours we write on the company API. That's the API with our company data. It's the old one. The new one is Lukas going to talk about in the next talk. And we have a pipe drive-like software we noemen het pipeline, and it's with our leads. Also connected that to our company API. And these are all tools we build ourselves. But we need a lot of more tools. Writing hours. No. I don't know. Our meeting rooms have little iPads where we can reserve those rooms. Declarations need a place where we can add them. And we ask ourselves the question, do we make all that software or do we buy it? So that's the make or buy decision. And recently we discovered that we don't have to buy them all, or make them all, so we can buy them. And we bought Robin for the meeting rooms, Harvest, so can write our hours. Expenditure is to do our declarations, and here is to do our. I'm not having the best time.
Monday.
Yeah, I had a rough weekend. Anyway, more tools. So, the new planning tool. But what we need is a tool that does micromanagement. So, macros. So not really big over the weeks, and not for every colleague parts of the days. We have changing teams, we have flexible skills, we have flexible locations, and all the tooling we looked for didn't really have that. So we had to make it. But how? That was the next question. We had some requirements. It has to be solid and trustworthy. We had to be able to see who made a certain change in the software. We need some revision history compared to the current state of our planning to other moments in time. And that's, well, a bit hard when you use the regular setup. So we had event sourcing to our rescue. What is event sourcing? It's a design pattern when you only save and process facts. And a fact is something which is true at this moment and will always be true. So keep that in mind. For example, a general ledger of what is it? A logboek, a grootboekrekening, where every mutation is written down on a certain rule, and together you'll have the state of je boekhouding. Ik heb er geen idee.
So, who here does not speak Dutch?
No.
There's one guy, I think.
Normally this is not so hard, but today it's well.
I think you missed
I'll take a minute.
I think you missed one important part where you were actually trying to say that every entry in the ledger has a time. So that means it's a true fact, even though there's no the current amount of money on your account is not what it was then, but at that time it was that amount. So it's still a true fact that the amount was at that time that much. So
Yeah.
you were trying to say that.
Well, you can use time or you can use a certain order, but the order never changes.
Yeah.
So you can always get the latest state by looking at all the facts that are there, and you can use an order or a time or anything else to keep that order in place. Why do you want this? Did I miss one? No. Well, you have less impact of bugs. You're reading and writing. I think I miss a sheet. Well, some things that work better with event sourcing is you have less bugs. Your reading and writing are separated, so you can optimize the reading and you can optimize all the writing. Bugs are easier to reproduce because you can go back in time and see what was the state of the application right at that point. So it's easier to reproduce your bugs. And the immutable storage helps you to switch your production data to development data. So you can reproduce bugs right there. Let's take a step back. Event sourcing was about facts. And one of those facts is an event. That's the smallest amount of information you have. And this is an event we have in our planning. And it's a schedule. You set for a certain week, in a certain year, a project, employees and hours. So I'll plan myself for 0 hours on the project with the strange ID in week 2 in 2007. And this is one event. And I can have another one, and another one, and another one. And all those events together make a projection. And a projection is something like this. For me, I have several projects I can work on in week 3 of 2007. I work for a total of 40 hours, and in this case, I am booked for 8. How do you get a projection from all those events? There's 2 ways to do that. First, you can use a batch, which runs every, well, in this case, every 5 minutes. It's a cron job, and it gets all those events, gets them through a function, and it results in a projection. This is a place where this can be slow because it's a cron job. It don't need to be real time. Non-critical calculations can be done here, and it doesn't have to be fast. On the other hand, you have updates. You have a projection, and you have an event, and you want that projection to project the latest state. So if you have new events, you're updating your projection with an update, and that has to be fast. So how are you handling those events in Meteor? This is an example which I think is quite easy. With your events, you insert, and when the insertion is done, you update the projections. And I think I miss a return here. If we have an error, I console log and I continue. That's not right. So all those facts, all those events we have are now in a collection. And what we need to do is make a projection out of them. So that's all those events, we get them through a function and we transform them to this projection, and how that function looks like is totally up to you. But this is the information I need. This is where my my UI is made from. So, what you need with event sourcing is you do a query to get the latest projection you have. And in Meteor, this is done with the publications, for example. In this case, we subscribe to all future weeks. So in our UI, we will see all weeks from now. And because we do it in a collection, all these changes are pushed to all the other users. So in case of a planning, where several colleagues are working simultaneously, if one changes something in the planning, it fires an event. The event is picked up by the update process. It updates the projection, and everyone is seeing that projection. So it changes for other users. Let me demo. We don't have to say anything. So this is the current state of our planning. We're not finished, so you're the first to see this, actually, except two of my colleagues who could work with this this morning. As you see, it needs a little styling, so this is pure functionality, but this is what our planning is. We're planning colleagues, that's the row on the left, over several weeks, that's the horizontal rule. And for users, we can plan for several hours that week, or we can just say, no, this project is your main project. This is the main project you're working on, and everything else is less important. So, for example, we take Christian. He's working on the Van Gogh Museum, SLA, and he has passietijd, one of the things we do here. He has some vacation days, some holidays, but he also works on the Philips project. So we're filtering for projects. It's this one. We're adding it to Christian, and we see it's right there, and it's his main project. He's working on this for, I don't know, forever. So this is for Christian, it is for Philips, it has a begin as an end. It repeats weekly, can be bi-weekly, every 3 weeks, every month, and it's his main project. And what we see here, if we change this, it calculates automatically what the hours, which hours are left, and it plans on that project. So Christian works for 40 hours, and in his first week he also works 4 hours for passietijd, so that leaves 36 hours. But for example, if Van Gogh needs him a little bit extra, a day extra, and we change that, it also changes the hours left for Philips Hue. And every change we make here is an event, and all those events are together represented by this projection. I can change this back and make it 6 hours. Another upside for this way of working is that we can get a little bit of logging. So here you just saw what I did for Christian. Every change I made, we can see right here, and it's really handy when you're with a team of 4 or 5 people who all change this planning. You want to see how come he's for 6 hours, or why is this his main project? Who fucked up? Now it's this. Now you can look who did that. In a regular application where you have a SQL database, when I change this 6 to an 8, that 8 will be the latest state. And there's no way of retrieving what was the previous state and who did it, and unless you keep a log or some kind, and you want to read text files and see who made every change. Underwater, this is kind of what databases do internally, but they always show you the latest state. And now this, now we do this ourselves with upsides to like logging, but we can also compare. And it's not done yet, but the idea is we can compare it to another snapshot in time. So compare it to a few days ago. You can see this one is changed. It's now 6 hours. It was 0 hours, and when you click on it, you see the logging on the side. And so for everything in this grid, you can see how it was planned. This is the deposit item. We plan it for all users at once. So where the colleagues in the previous tooling had to do 4, tap 4, tap 4. Why? Oh, I'm in the. So on the previous version it was 4, tap 4, tap 4, tap 4. And if they went too fast and the network didn't work too well, they lost this. But because we use this event sourcing, every event is saved. The state is always, those are the facts that are always true. So the state is always correct, and this helps them. Well, some other things we can do now is we filter on everyone who works in our Amsterdam office, knows iOS, and don't mind to work in the Hague office. And now we see all these colleagues. We can give them another project. And see who is available. That's unfortunately those are the same people. But when we give Matthijs another project like this, we can sort by availability, and we see all available people at first. Also here we see that, and everyone that has a project planned is on the bottom of this. Projects can be shown together. We can add weeks, so we can go all the way in the future. This is in short how our project works. Something else here? Oh yeah, those are the tests. The event sourcing is pretty easy to test. So we have the batch process, we have the update process, and both are tested. Because it's the core of our application, it was really important to test this, because if something fails there, the whole application crashes.
Do you actually store the projections in Mongo as well, like as cache values, or is it all in memory?
No, we store it in a Mongo collection with the upside that if you change something, the collection changes and every other user sees those changes. So that's...
Is it working with an observer?
With an
Observer. Like if there is a new event, then the recalculation is done via an observer. So it listens for every new event, and then it generates these calculated values based on that. Or,
Now we listen to our own events. So every event is a SERP call, Meteor call, and we save the event to a collection. And if that's done correctly, we update the projection. And the only upload there is it's of MongoDB itself. So it was really good for us to plan this because it's the core of our application. So we're using Meteor, MongoDB, and GraphQL. To use MongoDB and GraphQL was a really good combination. Lukas is going to talk a bit more about that in a second. And we're using React. We're really happy with this stack. We also considered plain Node.js or C# with Firebase, but the upside of updating a collection and everybody else seeing those changes made us choose for Meteor. We have a production-like setup: AceLint, unit test, Travis integration, code climate integration, continuous deployment. So although it's an internal project, we really wanted to go for quality. I think we did that. So next for our application, first is design. This month is our testing period. This morning, 2 of my colleagues started implementing the whole planning for all 65 people here from scratch, and they were done within an hour. It was really fast. Normally, it will take them a morning just to update the planning, and now to create everything from scratch, it took them an hour. We're going to fix some bugs, and after that we're going to explore whether there is a market fit for other companies, because it really helped us. And in our search for tools, we came across lots of companies who also had similar problems. So maybe we're not the only ones needing this. So event sourcing, although I may not make it really clear, it's a design pattern. The state you made is made out of facts. You don't necessarily need a framework. When you use Meteor, you have the events. It's like a little part of information you can store in the database. Your collection. Queries are done with publications. Projections are saved in a collection. And if you use those 3 things, you can have an event-sourced application, and you don't need a framework. There are some frameworks for event sourcing in Meteor. We looked at them, but they're too complicated. It could be much more simple, and it helps with all those things. Less impact of bugs, optimizing performance. You can go back in time and see what was the state at a certain point of time, so you can reproduce those bugs you get from customers. It's no silver bullet. When you use it, there will always be other challenges you have to face. But for an application where state is really important, where several people are depending on a good state, I would recommend using it. Thankfully, this is my last slide. So.
Thank you.
Any questions? Yeah, can I? Yeah.
Okay. But which starter kit did you use, or did you use starter kit, and which one was it? Or?
No, we didn't. We all wrote this. We wrote this ourselves.
Right.
Yeah. And it's quite simple to do this yourself. When you read a little bit about event sourcing, Martin Fowler has a really easy page. Look for event sourcing. It's the first hit on Google. He describes certain things you need to do to insert an event sourcing pattern, and all those things are really easily done with Meteor yourself.
And then the next question is, did you use a starter kit for the Mongo, GraphQL, React combination?
No, Mongo comes with Meteor. And for React, we use React Composer and React Router. More about that later, I think. A little bit. A little bit about Composer, I think. But yeah, Meteor Composer and Router, and works really well. Yeah.
Thank you.
Now, I'm completely ignorant to Meteor, but I do have a question about how it works. So I don't know if the other people know. But you say you make an event, you store it in a database, and your projection is then calculated.
Yeah, the calculation we do ourselves.
And is there a single process that is the safeguarding process of the truth? That's the hardest part of event sourcing, is to get the truth out in such a way that you don't have concurrency issues.
Yeah. Every event we make, we push to the server, and if the event is successfully saved, we're updating the projection. And if that projection is updated, we push it to the Mongo collection. And because everybody else is subscribed to that collection, everybody else gets those changes.
So you do have sort of a view in the same database, but it goes through a separate process that aggregates it into your current state.
All one process. It's Node.js, right? Everything's running in Node.js.
Yeah. And it's a single server.
Well, Mongo is not in the same process.
No.
So the hard part is that if you want to do an update, you want to update against the current state.
Yeah.
Else you're not doing it in sequence. Because everything needs to be strictly sequential in event sourcing. So I was really wondering how you would, if you solve this problem with it, because I was thinking that you used a view in Mongo to calculate the state, but you're using a separate logic to do it.
Yeah, when we add an event to the Mongo collection, we get our latest state and we update it with the event that's coming in. And because it's single threaded, that part is not really a problem. If we have a problem, we always have that batch process, which is running every several minutes, which is calculating the latest projection according to all those events we have. And for events, we also use a Mongo database. But we ensure that the order we inserted in is always kept the same.
We use MongoDB cat collections. So you allocate a fixed size in the database for this collection, and that's called a cat collection. And then you can append to it, but you can't change it or delete it. You can only append to it.
Yeah, the event log.
Yeah. No, well, a cat collection. It's not the event log, but it's probably used for the same thing.
Yes, you use the collection for your event log.
Yeah. So we built our own cat collection. Yeah.
Okay.
But the problem, if you don't have a cat collection, is that the order is not secured. It's
not guaranteed.
It's not guaranteed. So when you change servers or change, for example, we run everything on Compose and we go to another database server, the order might change if you don't use get collections. It's not very likely, but it can happen.
Yeah. Have you rebuilt your state from your event log? Because that's one of the very strong points is that you can just throw away your state, kill your server, start it up again, and calculate the current state from all your deltas.
We do that every 5 minutes. For now, in development.
Yeah,
so we can change it.
Would you do snapshotting?
We do snapshots, but those are only to compare our current state with an older state, so we can see what changes are made over
two snapshots.
No, between now and a snapshot. Yeah. But well, it's 2 snapshots. Yeah. But because the time we need to do the full batch is within 1 or 2 seconds, so it's not really long. So we don't need snapshots at this time. But in a year, or we calculated this in a year or 5 to 10, we might have so much data we need that, and by then we will build it.
Because you rebuild the state every 5 minutes, isn't there a chance of a race condition in the 2 seconds you need to update the state?
Yeah. And
how do you fix that?
Don't do concurrency.
At a certain point, we start the batch process, so we know until which event you started to do the batch. We do the batch up until then, and everything that's new is done as an update on the result of the batch. And when there are no changes anymore, then we switch the projections.
So of course there's an error window that's really small.
Yeah. And if we do it wrong, in the next batch process, there's always a chance that you... No, it will get it right, but there's a chance you'll get it wrong again with or working on it.
If then someone has more hours than available, it probably throws an error somewhere, so you can fix it.
You get a big red number and screen and you can fix it.
Okay, yeah.
Yeah.
Why do you rebuild it every 5 minutes? Normally you rebuild when we start, or when you add another view.
To be sure it works.
Yeah.
We're in development, so...
We're doing more often, yeah.
Yeah, but normally we will do it if we start the server and there is... well, you can do it when you start the server and there is no projection. You can do the batch process. And only work with the updates from there. But for now, we really want to be sure it works, so we do it more often to test it.
Last question.
Yeah.
Is it also possible that you design it or build it in a way that you can also refer to process, so you go from this projection back to a state somewhere in the history? So if you have like a very long collection of states, of a lot of facts, and then it will take a lot of time to go back to the end. But if you have the end and you want to go back like 2 hours back, can you also do that? Is like part of the design?
You can always save on build up until this event.
But then you will build up from the start again.
You can build up from the start. Okay. What you just said is you can always make snapshots after a several amount of events. So when it's going to take a lot of time to build from scratch, you can decide after every 1,000 events we're going to create a snapshot, and everything from there is just an update on that projection. So it will be faster. And you can always say we'll delete some events if we make too much, or just go and calculate the state up until this event.
Yeah, so but you cannot go back strictly.
That's
a really question.
Backwards,
no, you can't.
You can go backwards 2 ways. Just delete a whole bunch of events and you're back, or add every event in reversed order at the end. So.
Yeah, but the inverse, you don't know the inverse.
Yeah, that's mainly the question. Is there have you built like a pure function that has an inverse? But that was I think the question.
Yeah, you can calculate the change between those two snapshots and insert it as a new event. So you can go back, but well, you really have to see what.
Doesn't work in a generic sense.
No, not in generic sense. You're gonna create some. You're gonna get some difficulties, but I think you can manage it in every project.
Cool, thank you. So grab some drinks and beers, and if you're still hungry, there's still some pizza, so you can grab that. And then in about 10 minutes, I'm going to start with the next presentation. That's the last one. No thanks.
Zit even daar. Ja, no.
But you can also if John wasn't here, we probably have used those.
So? Yep. Ladies and gentlemen, we're going to start again in 2 minutes. I think it's lady and gentlemen. You're like the only lady. Thank you very much. Did it do that during the presentation? I was just immune to it. I hear it all day. Yes, I'm waiting here. So I've been working with together with Bob on this this planning project, but I did a different part of it, and I'm going to talk a bit about that. So I'm going to present the case a little bit, walk with you through the code, and different pieces of the code that I think are interesting. And the last part, I'm going to do a little bit what Bob mentioned, the composer side where we're the client for the GraphQL API. So, the case, we have a lot of data, and so these are a couple of the, well, these are the data points that we're using for internal projects like the planning. And so we have Mongo database that has project employees and customers, just the core data. But we also have Harvest where we do the entries, so that's one of the buy decisions that Bob made. Timetastic for vacation requests. That was the weird purple guy on the desk. And we also have a couple of Google Spreadsheets. So, for instance, we have one events. We have an internal Google Spreadsheet that has all the information about what Q42 employee is going to a conference or an event or a workshop, or if they're talking there. So those kinds of things are in that spreadsheet. And what we want to do is, when we're looking at the planning, we want to make it as easy as possible for the planners to enter this. And how easy is it if it's just entered automatically? So for instance, the feestdag, the holidays, this is test data, but they're inserted automatically just from the known Dutch holidays. So this is probably like Easter and Hanukkah, I don't know. So someone knows. So these hours are automatically inserted based on just Dutch holidays. And these vacations are also inserted based on the vacation request that Taco did via Timetastic. And because GraphQL, or because the planning is using our GraphQL API that is using the Timetastic API, we can just show this kind of data. And even the events that we keep in a Google spreadsheet, they're automatically entered into these into this system. So this is just the way that we can really help the people that do the planning at Q42 to make their life easier. The code. So we when we started this, it was the question: do we want to take the Meteor project that Bob was working on for the planning and add a GraphQL endpoint to that? But in the end, we opted for having a separate GraphQL API endpoint, which is an Apollo server just running on Node.js Express. So it has no knowledge about Meteor or about DDP or about that kind of thing. It's just a single purpose application. If you guys have questions, then just shoot. I'm just going to keep talking. The code is pretty easy. The way I see it, GraphQL helps you a lot. It has the three main distinctions that we use in this project. We have schemas, we have resolvers, and we have connectors. Don't mind the middleware, it's authentication, that kind of stuff. So in the schema, you just have a customer, an employee, a project. So these files determine what this entity looks like and what query you can do on GraphQL. The resolver is if I ask the name of a customer, the resolver determines where that comes from. Does it come from a SQL database? Does it come from a Google spreadsheet? Does it come from wherever? So the resolver has that knowledge, and the connectors are fetching the data. So we have a MongoDB connector, we have a Slack connector to get people's usernames, Timetastic, and contact lists and events. But for instance, these two are Google Spreadsheets. Small question: who has worked with GraphQL? Like really created an application? Who has never heard of GraphQL and just wants to know what the hell is it? 2 people, 3 people. Shall I do a quick? Can I do this? So if I go, for instance, to HTTPS GraphQL. I like this way of showing it. GraphQL is an API endpoint it's an API with one endpoint. And based on the query you send, decides what kind of information you get back. So in this example, when I just go to GraphQL Q42.com, of course I'm logged in, so you're not going to see anything. I can determine myself what information I want to get retrieved. So if I do this, employee, I want all employees and the ID of them. Then these are the employees with the ID. And if I add, so I was talking about holidays, and they have, so you see, this is an API, it's machine readable, but it's also user readable. I can just type the query here and I get code completion, stuff like that. And this is just an interface based on GraphQL. This is called GraphQL. But it's a nice way to show what's possible.
Can you please zoom it a bit?
Zoom in?
Yeah.
Maximize screen, and then that's not helping, right?
Yeah.
Plus. Yes, you can read? Nice. So this interface really shows the power of it, and GraphQL comes from the factories of Facebook. They're using this for their for the Facebook app, and one of the things that makes it really powerful for apps is it's very low bandwidth usage because the client determines what information it wants to get. So if I want, for instance, a list of employees with their holidays, I don't have to get the employees with all their data inside of it. I only get the information that I'm requesting, and each node in this tree, I can decide via those resolvers where it comes from. So let me give you a small demo of this. I like this demo because.
So you get auto completion because the schema is declared?
Exactly, yeah. So in those schema files, I declare my schema, and that's why this interface. So one of the things that GraphQL does is expose the schema as a query, as queryable.
Yeah.
So for instance, in an employee, I can get __. Oh, it's not auto completing that. But you can get the type of the result that you're getting. And so it has all this class stuff built inside. You don't need to know it. But it has the end result of being able to do auto-completion.
It's like doing an options HTTP request, getting the type.
Yeah, it's kind of like an options request of what can I do, what can I request. That's what GraphQL does. It does one query to get the schemas, and then it builds this interface. And you decide yourself what you want. And you can also pass in parameters, parameters. So I can do employee ID is Lukas at Q42.nl, holidays. So, oh my God, this Thursday I'm going on winter sports. I like that demo. So this is the holidays, this node in the query. That's coming from the Timetastic API, and via the Timetastic app, I requested my vacation, and it has. I can also request the status if it's pending or if it's accepted, stuff like that. But just as a short intro of what is GraphQL, I really like this. Does it make it a bit clearer? You too? Awesome. Now see if I can go back to my. Right, so we have the schema where it said employee has holidays and holiday has a start date and stuff like that. Resolvers determine where it comes from, and then the Timetastic does the holidays query for a user. Schema looks like this. So this is a customer. The customer has an ID. It has a name. The exclamation mark means that it's an obligatory field, so you always get it back. Customer status is defined as an enum up there. And of a customer, you can request its projects, and via these brackets, parentheses, what are they called? You can optionally give them parameters like the status, and then you get back an array of projects. So it's kind of like a bit JSON-y, but then a bit different-y. But it's pretty readable, and it doesn't have a lot to it, so it's pretty good to read and to write. Resolvers are pretty neat and easy. So when I request a customer and I request the ID of a customer, you just get the entire customer object, and you can say I want to return this field, or you say when projects of a customer are requested, then I go to the database and I get projects by customer with this ID. So there's not a lot of code here, but it just ties the query that you're doing to the connectors that are behind it. And the neat thing is, if we go back here, you notice name and status, they are here, but they're not here. That's because those fields don't need to be transformed. So you see the ID is transformed. The underscore is removed when it's published to outside. Name just stays name, and that one is added automatically. Because it's in the schema and because it's in the results set that's gotten from the database, the resolver doesn't have to do anything, it just passes it along. And that part works like magic. So this is a connector. Get customers with arguments. Return collections customers, which is a MongoDB thing. So I'm not using Meteor. So I don't have like my I don't remember what it's called.
Collections.
Mongo collection, yeah, exactly. I don't have Mongo collections with a capital C, but I have just the native MongoDB driver is what I'm using. It also has the find, and instead of fetch, it has toArray, but it does have a then. So the connectors don't have to be very difficult, but they do the actual data fetching. And what I found to be a nice way to implement a connector is this, typical connector setup. What I liked about GraphQL is it really helps you also pre-cache the stuff that you want to deliver to customers. I'm relying pretty heavily on external APIs, which don't have to necessarily be fast. So in a lot of cases, I want to pre-cache that information, and then when someone requests it, I give it from the cache, and in the background, I just update the cache every once in a while. The way I do that is having just a cache element and saying this connector isn't ready yet, and the startup script, the booting script of the application executes a constructor, then execute the init, which fills the cache and then sets it ready. And there, in the hosting solution, the is ready is here for the hosting solution to only publish this version of the app when all the is readies have been done. So by the time that version 1.0 and 1.1 are swapped, 1.1 already has filled caches and is ready to handle the load that it's going to get from all those people that are using the planning. And of course, this is the outward-facing API of connector.getItemById, and it just gets it from the cache.
Did I get you correctly that first, when you do the first request, you get it from cache, even if the new data is coming, and then you are getting, on the second request, you are getting the fresh data?
No, I'm hosting it using Kubernetes, and Kubernetes has this there's a server up and running. It's the production server, and when you put up a new server, it has two servers, and this one is booting, but only when the /ready URL returns a 200 OK. That's when it swaps the traffic and it takes the old one out. That's what it's used for.
Okay.
Does that answer your question? I don't remember your question. Did it answer it? Cool. We rely pretty heavily on ECMAScript promises, like these REST APIs. So we're using request promise, and you can just do request promise with some parameters, and then you get the data back. It's pretty easy. But for instance, the harvest APIs need to be throttled. You can only do X amount of requests per X seconds, something like that. Those exact numbers. So here we have that same line, a request promise dot bind this, and those parameters of what you want to get. But I just added these 6 lines, and now it's throttled to only executing 5 of those requests per second. The way promises work really make these kinds of implementations easy. And also the data loader. I don't know who was at the Lively event, the last Meteor meetup at Lively. Jesse gave a talk about data loaders there. So I thought most of you would have known it, so I won't go very deep into it. If you want to know more, then please ask me. What it does, this is the before I implement a data loader. Get employee returns employees.find. That should be the find one. And when the downside of that solution is if I have 1,000 projects, and for each project I want to get the people working on that, which is an array of IDs. So I want to do to get that employee, but do it 1,000 times for each record. So I want to bundle those, and that's what data loader does. So this is where I say get employee. This is the outward-facing API. I want to get this single employee, and I don't want to get it directly from the database. I get it from the employee loader. And what that employee loader does is wait for all the queries to that employee loader to have finished. So then instead of ID 1, it wants to get 1 and 8 and 10 and 1,000 employees. And then it does one query with those 1,000 employee IDs, ID in keys, and it returns that. So this makes it a lot more performant because you don't have to go to the database 1,000 times, but you go once to the database with 1,000 keys. So it's a big query, but who cares?
How long do you wait?
Hmm?
How long do you wait? 45 seconds?
What for?
So you wait until all the queries are in for that particular collection.
I have no idea how data loader does that, but data loader does it.
It probably buffers up to 1 second.
No, it's not time-based. It's not time-based. When it, I expect it to go once it's passed all the elements in the GraphQL query.
One single query.
Yeah, because I do. Yeah, exactly. It doesn't. It batches it in one query. This is done in one query.
You use Apollo, right?
Yeah.
Because Apollo aggregates the queries and then makes one big query, and data loader.
But not for concurrent requests, but within a single.
Yeah.
request. Yeah.
Yeah. Yeah, exactly. This is.
There are no concurrent requests because just one query is being executed.
Yeah,
Yes,
but you could.
There are concurrent requests if you have multiple users.
Yeah, exactly. So the data loader is used for one user.
Yeah.
So it's bundling. If you do one query with 1,000 projects, then it bundles these. It doesn't bundle them over different users. I would not want that. So that's data loader, and there's a really good video of it of last meetup. Authentication. So you don't have Meteor users. What do you do with an API that has no user interface? And what I ended up using is Google tokens. So in the planning app, you log in with your Google credentials because Q42 has a G Suite Google thing. So you log in with your Google credentials, and then the access token that you get back, that is also refreshed with a refresh token, and I mean the planning does that stuff. But the access token gets sent in a header to the request that you're doing to the GraphQL server. And we are going to Google APIs to request, this token is doing a request, who is that? And then I get back, this is Lukas at Q42.nl, and then I can go to my employees collection to see if that user exists and what privileges he has. So this is one of the middleware things that you saw in the file descriptions. Pretty basic stuff.
So there's no password authentication or anything in your database, all done through Google?
Yeah. 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 Not quite. Not quite, because when you go to graphql.q42.com, it's really cool that you see that that graphical interface and just can play around with that user interface. And I want to open that up also to other colleagues to just play around with the data. So I want people to be able to log in without having to get a Google Access token and pasting it in a header and opening Postman and stuff like that. So I implemented a second authentication method, and that's just the Node.js passport, what's default there, session storage, stuff like that. So it actually also has its own Google OAuth thing, which is crappy to set up if you're used to doing Meteor accounts and just Meteor add accounts, accounts UI, accounts Google, and then it works. This is infinitely more complex. I just showed it at the beginning, but Graphql is awesome, and it gives you. I'm going on winter sports again. It gives you insight in your data, but it also gives you the option to add a node that you don't know where to put in a user interface, but you do want to do the calculation somewhere. And I've encountered I've done two GraphQL projects, and in both I didn't start out exposing Graphql to users, but at some point they asked a question like, can you do this and this query and combine it with that and then give me the numbers? No, I'm not your webmaster. I will create an endpoint and then you can do the queries yourself by user or by project. So I ended up to use Graphql as just a UI on the data and really exposing that to users. And let me see. Yeah. So this is the example that I had internally on the Q42 GraphQL interface. Someone was asking, I want to do the I have to close the books of last year. I don't know, accountancy stuff. And he said, how many hours has everyone worked on billable projects, on customer projects, versus the planning and because we're not paid for this stuff. So he wants to know how many hours have I worked on paid projects and how many on non-paid projects. And I could have gone into the database and figured all that out, but it's quite some figuring out. So I created a little, I added this to the schema and made a little resolver that gets it from connectors and molds it a little bit and then outputs it. And then I just send a deep link with this specific query to our accountant, and he can just read these numbers. All he has to do is press play, and then for 2015, I I forgot to put the ID here. Lucas was, I worked 40 hours, so that's 2,000 hours. And these are the billable amounts. Instead of having to put up, I don't know, how do you do that? Like make a Google spreadsheet out of it, download it all, and then update it when he wants an update of that information. So I really like this, this added bonus that you get of Graphql. And the other API that I worked on was for Codeuur, so the Dutch hour of code. It's also a Meteor app which links schools requesting a programming class to vrijwilligers, volunteers that want to give a programming class to those. So it's a matching engine, and so just to get a feel for GraphQL, I created a GraphQL endpoint, and I'm using it at some points in the site. It's just a classic Meteor iron router Blaze old crappy site. But I managed to add a GraphQL endpoint next to it and use that data at some point in the site. And I also decided to open this up. So, and this is a Medium blog post that I wrote about it, where I'm asking people to, please, if you want, you can just query this information and do with it what you want. Of course, the privacy-sensitive information I took out of it, so you can search for the guest teachers that work at Q42, but you can't find their names. But you can find the company and the status and how many classes have there been given. So for instance, Microsoft is sponsoring a lot of resources for Codeuur. They want to know how many employees of ours are actively giving classes. Well, now I can just send them a query, and they can see themselves of how many people are there and how many classes are they giving, and that information. Pretty nifty. How I said that at the start. So now we have GraphQL, but we also have DDP in the case of the planning that Bob was talking about, because all the information about the hours and the events and the projections, that's done via DDP. Whilst the information about the employees and the projects and the holidays and stuff like that is coming from a GraphQL endpoint. So we're using both of these, and we're using GraphQL for the lists of information that aren't very volatile, so they don't change very often. GraphQL is built to manipulate data before sending, so it has caching layers, and it has like these the resolvers where you can decide how you want to return it. It's built for cacheability, whereas DDP is, you have to do a lot of coding yourself if you want to cache it and if you want to do stuff with it other than just exposure collection to the client. It's flexible on the server, as in you can use any data point you want, even SQL, which I'm not using, of course. And it's also flexible on the client, as in you can just do a REST call to a GraphQL endpoint within the body or query string or somewhere. You can pass in the query, and you get the result in a JSON parsable result. But you can also use like Apollo client or other iOS clients or dedicated things that have caching layers and that update and that subscribe and stuff like that. So also on the client it's pretty flexible. And I love Graphql, where you have UI on your data that's also like a halfway point where you can test. You can just create an endpoint and then test it and in different use cases before you attach your own user interface, React, Vue, whatever, onto it. Whilst DDP is built to send partial collections, and that's what we're using it for at at the planning tool. It's real time, and it has Meteor, which is an upside because you don't need Passport for authentication, Webpack with all its crappy configuration for your bundling and deployments. Babel is built in. Meteor has a lot of advantages, but I don't have to tell this crowd. So what we end up with is the planning where this list of users, and if you expand the user, the projects are from GraphQL, and the numbers here, the weeks projection, are via DDP. And I said I was going to talk a little bit about that client side. What I'm doing is, this is like a bit more complicated, but this is just a normal GraphQL query. It's a string. It starts and ends with a backtick quote thing, where I say I have this query and I want to get all the projects that are plannable. And of that project, and of each project, I want the fields that the sidebar needs. So on the right side, you saw all the projects that has a specific need, the sidebar and the user expanded row. So when you expand one row, there are different fields needed from a project, and they are imported via fragments and complicated stuff. But this ends up just by being a string GraphQL query. And then this is the part where React Composer is added. What React Composer helps with is separating your view from your data fetching. So what happens here is planning is the view. It only exists of HTML and CSS and maybe some other React components, but it doesn't have any data fetching. It just gets all the data via the props, and those props are created by its parent. So these two are its parent, and for some reason they're going from down to up. So I'm doing my planning query that we saw on the previous slide with a GraphQL that's from React Apollo. I'm executing that query, and the result of it, so this is like the top node, the result of that query is passed as a prop into this composer query. This composer query has all the DDP stuff, so it's doing projection.find and stuff like that. And those two are combined and sent to the planning. So this is the topmost element that gets all the projects, all the customers, and all the weeks. It molds it into a data thing that you can iterate over, and then it gets passed via the props to all the underlying nodes. And this is what the DDP looks like. So this is the top one in the merge. It gets props.data.projects, which is the syntax that Apollo Client uses. It gets that list of projects, and then it gets the hours planned totals, which are gotten from the DDP connection, and it combines those. For those of you that have played along with it, that have played with Composer or React, or it might mean something, and maybe you're just blank. What is this?
In the previous slide, sorry. In the previous slide, the get tracker loader is a function that you defined yourself to get the DDP stuff for the timetable, right? It's not a built-in function from Composer.
It was. In React Composer 1.x, it was included, and then in 1.x+1, it got taken out. And this is by Aeronota, of course. Everything's by Aeronota. And Aeronota put in the changelog, you see, if you want get tracker loader, then this is the code for it. Use it yourself. Yeah. So it depends on which version you use. Yep. So that was my presentation, and I just wanted to show his awesome. This is like Q42 delivering a kid. How awesome is that? This is the reason that I wasn't present at the last two meetups that I was with him, and that's the last of my presentation.
Nice.
I'll bring like an applause sign. So questions? No, was I that clear, or are you just dumbfounded? What is this?
Is that awesome?
It was that awesome.
I have one question, but it's actually from my programmer.
Yeah.
He's asking, what do you think about Vue? Vue.js?
Love it. I'm actually now doing a project with Vue. I like, this is way off topic, but I like Vue because it's simpler or easier or more predictable. It has less magic. It feels less magic-y than React. And also, if it says anything to you, I hate Redux. It's just too complicated. And Vue has the concept of stores, which are do the same thing, namely share state across multiple components. But it's just really done really nicely.
Okay.
If it says anything to him, you can pass it on.
I will pass it on. Yeah.
Cool. And I don't think Vue has a really nice way of working with Meteor. There's probably some packages, but the MDG is really working with Angular and React and a little bit of Blaze. But I haven't heard them announce support for Vue very openly. More questions?
Are we going to see GraphQL replacing APIs in the sense that companies will expose GraphQL endpoints rather than APIs? Or is it just going to be something that pulls together several APIs to give added functionality just at one point?
I think both. What you're now seeing is that, for instance, Facebook, but I mean, they're the creator of GraphQL, so it shouldn't be a surprise. But also GitHub has opened a beta API on their information, beta GraphQL API. So that's just like the last endpoint where you're connecting with their information systems. But for instance, if I want to get all the GitHub projects that a Q42 employee is working on, for instance, me, I can add that in my own GraphQL. So my GraphQL server gets stuff from GitHub's GraphQL server, and then you can also chain them and combine them and whatever the need is. Yeah, it can just help to only add a caching layer or only just mold the data a little bit before you pass it on to someone that's waiting.
But it's definitely only a pull model.
No, there's also a way of pushing data, of doing changes.
You can subscribe to events, right? So you can do a query and subscribe to changes on the things you queried, or you can. I think you can even subscribe to events in general.
GraphQL has a lot of concept. It also has subscriptions, so you can do a GraphQL query and then get updates as they're happening, like DDP out of the box does. So GraphQL has that, and there's
mutations.
Mutations,
right? It's like.
Yeah, exactly, mutation. So instead of only fetching data, you can also send a mutation, which is like a Meteor method, pass that to the server, and then it goes processing it. And the Apollo client, so Apollo is one of the implementations of GraphQL. It has a server, it has a client component. And the client also has like the optimistic UI functionality that we know from Meteor, that we know and love from Meteor. So that when you do a mutation over GraphQL, that it in its internal cache, it also updates that so that the UI is instantly reflecting the change that hasn't been seen by the server yet. So those kinds of systems are being built, but they're also heavily on the client side, where GraphQL just has this is the data, and I can give you updates if you want. If you subscribe, I can publish updates, and you can do mutations. Was that it?
What was the main reason for you to choose GraphQL?
Mainly because we're using a lot of different data sources, and GraphQL was theoretically built to handle that kind of information combination. So I just wanted to try it out, and I like it. If I'd done it in, I mean, you can also just do this in Meteor and expose it over DDP or over REST or however you want to do that. But what I like is the simplicity that it provides you with the schema resolver connector abstractions that really make the code clean and readable. That you don't have versioning when you add or remove fields. It's just built for API stuff, and I like it. So I've done 2 projects with it now, and just internal things like Coder and like Q42 GraphQL. But now there's one team at Q42 also building this for a client, for a customer. So I've been able to infect other people with my enthusiasm for it. Yeah. Is that it? Then, one more?
Yeah,
Last question.
Have you already encountered handling authorizations? So that is someone who's logged in can access one data source but not another, or can access one field and not another?
I've done a basic version of that. I can show you in the codeur.nl graphical. This doesn't have an authentication method in front of it, and I can do this. I can execute this query, but if from a guest teacher I want to get its name, I hope I'm logged out. So now the name returns null. This is the way that I implemented. Exactly. So this is the way that I implemented it. You have the same schema if you're logged in or if you're logged out. Only when you're logged out, specific fields return null. And if you're logged in, then...
this is actually good for prototyping stuff. That you can, if you do testing, that it's sort of anonymized.
Sort of anonymized, yeah. Yeah. Well, you can, I mean, your resolver does this, so your resolver, you can just say return case.
Yeah, but you could also just let it crash, right? And just
yeah.
So you can bails out something else. Sorry, you can't do this.
Yeah, yeah, yeah. You can crash and then you don't return anything. You can also use so what you see here. Sorry, I forgot to enhance. This is the data root node, and next to it you can have an errors root node. So if something error happens somewhere, then you get either data and errors, or you get no data but you get only errors.
Oh, yeah, you can null it and give the errors. Like
yeah, yeah, yeah. You're requesting a name, but you're not logged in, so you're not getting anything. But then the client can still work with the data, and what he does with the errors is for him to find out. Yeah. I wanted to do that, but I haven't found out how I can just throw my own errors.
And this is a generic approach you learned somewhere else, or is this something you completely discovered on your own?
This way.
Yeah.
I completely discovered on my own. Yeah.
But it's also the way everyone does it.
Yeah.
Returning null on a non-authorized field. So.
Great minds think alike.
Yeah, yeah, yeah. I googled it, but I couldn't find anything.
Yeah.
So. Okay, well that was my talk, including Q&A. Please stay for beer, and the pizza are probably not done yet, so you can still have some cold pizza. But there's beers and there's drinks. Bob is back there, and I'm up here, so if you want to ask us questions about what we did, or if you want to browse through our code, I'd be happy to show you around in it. And otherwise, we'll see you at the next meetup. Thank you all for being here.